In this video, we're going to calculate the volume of a cone. Imagine a cone with a maximum radius of r and a height of h. To find the volume, imagine a thin disk with radius x and thickness dy. The area of the disk is pi x squared, so the volume of the disk is approximately pi x squared dy. So that's the area times the depth. The reason it's approximate is because the radius at the top is not the same as the radius at the bottom. But as dy gets smaller and smaller, the radius at the top and the radius at the bottom become more similar. So we can find the volume of the whole cone by integrating the equation that we've got from y equals 0 to y equals h. To carry out this integration, we need to replace the x term. So how do we do that? We can see by similar triangles that x over y is equal to r over h. So we can say that x is equal to ry over h. Substituting that into our equation, we can now see that v is equal to the integral of pi r squared y squared over h squared. We integrate that with respect to y, so we get pi r squared y cubed over 3h squared. We now put h in place of y, so we get pi r squared h cubed, but that's over h squared. So the h squared and the h cubed will cancel down to h. And then when we put 0 in, the term will become 0, which means that our final answer is pi r squared h over 3, which is 1/3 of the volume of a cylinder. So our process was to find a small representative volume, which was pi x squared dy. We then found a substitution to take x out of the equation, so we only had it in terms of y. We integrated it with respect to y, and that way we found an equation for the volume of a cylinder.